Charles Babbage and Akin. Let us tell the story of the hardware from the beginning. In 1936, Akin had proposed his idea to build a giant calculating machine to the Harvard University Physics Department. He was told by the chairman, Frederick Sonder, at this time that a lab technician, Lanza, had told him about a similar contraption already stored up in the Science Center. Akin had Lanza lead him to a machine which turned out to be a set of press wheels, like this as you see, from English mathematician and philosopher Charles Babbage, a unfinished analytical engine from nearly 100 years early. Akin immediately recognized that he had the same mechanism in mind as Babbage, but Babbage has no material to complete his dream and succeed. Later, this press wheel, along with a set of books that had been given to him by grandson of Babbage, would occupy a prominent spot in Akin's office. Press wheels were a small demonstration piece of the different engine one, not the analytical engine. They were one of 6 such pieces constructed by Babbage's son Henry after his father. These demonstration pieces were distributed among various universities, including Harvard. Akin must have been sufficiently intrigued by the mechanism of investigate Babbage. It's not clear when Akin was given Babbage book or what they contained. They didn't contain plans of analytical engine, since the only plans have always been stored at Science of Museum at Kingston in London. Akin may have been able to obtain some document which together comprise a complete published about the analytical engine. This document, along with Babbage book, would have given Akin a high-level description of Babbage planned machine. This is the Charles Babbage difference engine in the Museum of London. Charles Babbage analytical engine piece constructed by his son. In 1991, the Science Museum in London constructed the difference engine 2. The printer was added in 2001. These pieces are on display in the museum, which is well worth a visit. The construction of different engine 2 is documented by Drownsound in book The Difference Engine. Difference Engine 2 was the last machine Babbage designed and employs lessons he learned from both the Difference Engine 1 and the analytical engine. Note the drive shaft running along the bottom, the general arrangement with printer at one end of the long tall frame. This may be the result of convergent evolution rather than direct influence, but the similarity is still striking. For example, the printer was designed for use by analytical engine, and Babbage reused it for the Difference Engine 2. The similarity between the Difference Engine 2 and the machine that Akin built is striking. Yes, you can notice the similarity. In the foreword to the manual for operation of the automatic sequence control calculator, Ewald Akin stated that the appendices were prepared by Hopper with the assistance of others. She acted as general editor, and more than any other person is responsible for the book. It seems safe to conclude that Akin and Hopper were not only influenced by Babbage, but they and their team held him in high regard and considered themselves guardian of his reputation. Charles Babbage, in one of his writings, he say, "If unwarned by my example, any man shall undertake and shall succeed in really constructing an engine embodying in itself the whole of executive department of mathematical analysis upon different principles or by similar mechanical means. I have no fear of leaving my reputation in his charge, for he alone will be fully able to appreciate the nature of my effort and the value of the result. The staff of computation laboratory went on to have a considerable influence on the development of the modern computer, not least of which was Grasshopper, who developed the first compiler and several popular languages. Here she sits down beside Akin. The influence of Akin and IBM Harvard machine on the later development of computers should not be overstated. Hardware was very forward-looking and was excited by the mathematical potential of the stored program computer. On the other hand, Akin was absorbed in his own way of doing things and doesn't appear to have been aware of the significance of the new electronic machine. Unlike Akin and his machine, Grasshopper and some of her colleagues went on to have significant influence in the early development of compiler and language design. One wonders what, if any, influence Babbage and Ada Lovelace had on Grasshopper's idea. Unfortunately, I can find no comment by Hopper regarding either Babbage or Lovelace. The history since 1960. The history of computing hardware starting in 1960, marked by conversion from vacuum tube to solid-state devices such as transistor and later the integrated circuit. From the vacuum tube to transistor to integrated circuit. In 1959, the secret transistors were considered sufficiently reliable and economically that they made further vacuum tube computer uncompetitive. Computer main memory slowly moved away from magnetic core memory devices to solid-state, static, and dynamic semiconductor memory, which greatly reduced the cost, size, and the power consumption of computer. Third generation, the mass increase in the use of computer accelerated with third generation computer. This generally relied on the Jack Kilby invention of integrated circuit microchip starting around 1966 in commercial market. The first integrated circuit was produced in September 1958 and computer using them began to appear in 1960s. For example, the 1961 semiconductor network computer, electronic computer, MOL-E-COM, first monolithic integrated circuit general purpose computer built for demonstration purpose, programmed to simulate a disk calculator, was built by Texas Instruments for U.S. Air Force. The first monolithic semi-silicon invented by Robert Noyce and Fairchild. The integrated circuit enabled the development of much smaller computer. The mini computer was a significant innovation in the 60s and 70s. It brought computing power to more people, not only through more convenient physical size, but also through broadening the computer vendor field digital equipment. November 1966, Hewlett-Packard introduced the 2116A mini computer, one of the first commercial 16-byte computer. In 1969, Data General introduced the Nova and they shipped a total of 50 at $8,000. The 1965 IBM System 360 mainframe computer family are sometimes called third generation computer. by 1971, ELIAC supercomputer was the fastest computer in the world, using about 250,000 small-scale ECL logic gate integrated circuit to make up to 64 parallel data processor. Third generation computer were offered well into 1990. For example, the IBM ES 9000 announced April 1994 used 5960 ELC chip to make a 10-way processor. Other third generation computer offered in 1990 include the DEC VAX 9000 in 1989, built from ECL gate arrays and the custom chips. Fourth generation. The basis of the fourth generation was the invention of the microprocessor by a team at Intel. Processing power and storage capacity have grown beyond all recognition since 1970, but the underlying technology has remained basically the same, using large-scale integration and very large-scale integration microchip. It's widely regarded that most of today's computers still belong to the fourth generation microprocessor. On November 1971, Intel released the world's first commercial microprocessor, the 4004. It was developed for a Japanese calculator company called Biscom as an alternative to hardwired circuit, but computers were developed around it, with much of their processing ability provided by one small microprocessor chip. The RAM chip was based on an invention by Robert Dennard of IBM, offering kilobyte of memory on the one chip. Intel coupled the RAM chip with the microprocessor, allowing fourth generation computer to be smaller and faster than their computers. In 4004 was only capable of 60,000 instructions per second. 60,000 instructions per second, sorry. But its successor brought ever-growing speed and power to computer, including Intel 9009, used in many computers using CP/M operating system. The IBM personal computer and compatible use processors that are still backward compatible with the 8086. Other producers also made microprocessors which were widely used in microcomputer. Here the timeline for microprocessor: in 1971, Intel 4004, 1972, Fairchild, 1973, brought mini national IBM, General Instrument in 74, Fairchild F8 in 1975, in 1976 RCA CDB, in 1977 Intel 8085, 1978 Intel 8086, 97, 78, 8088, 1980 National Semi, 1981 DC1 Harris, 1982 Hewlett Packard, 1982 Hewlett Packard, 1983 Stanford, 1984 Motorola, in 1985 DEC Microvax, 1986 NIC VAX 60, 1985 DEC Microvax, 1986 NIC version 60, 1987 Acom, Intel, and till we reach the latest versions: ADM Vigesto, IBM Power, ADM Athlon, ADM Operating, and the most recent IBM Power R9. The supercomputer, the powerful supercomputer of the era, were at the other end of the computing spectrum from the microcomputer, and they also used integrated circuit technology. In 1976, the Cray was developed by Seymour Cray. This machine was the first supercomputer to make vector processing practical. It had a characteristic horseshoe shape to speed processing by shortening circuit path. Vector processing uses one instruction to perform the same operating on many arguments. It has been fundamental supercomputer processing method ever since the Cray 1 could calculate 150 million floating point operating per second. Mainframe and mini computer. Some of the first computers that might be called personal were early mini computers such as Link and DM8 and later VAX. Larger mini computer from Digital Equipment, DEEC and Data General, Prime Computer and others. They originated as peripheral processor for Minecraft computer, taking on some routine task and freeing the processor of computing. Microprocessor and cost reduction. In the mini computer ancestor of the modern personal computer, processing was carried out by circuit with large number of components arranged on multiple large printed circuit boards. Mini computers were consequently physically large and expensive to produce compared with later microprocessor systems. After the computer on a chip was commercialized, the cost to produce a computer system dropped dramatically. The arithmetic, logic, and the control function that previously occupied several cost circuit boards were now available in one integrated circuit, which was very expensive to design but cheap to produce in large quantities. Concurrent advances in developing solid-state memory eliminate the bulky cost and power-hungry magnetic core memory used in prior generation of the computer. McCrell. Originally, the computer had been designed by General Lecomte for the Institut of National de Recherche in France. The Altair 8800 and EMSAL 8080. The Altair 8800 introduced in January 1975. Popular electronic magazine article set a new low price point for its time. A microcomputer emerged. The advantage of the microprocessor and solid-state memory made home computing affordable. Early home microcomputer systems such as Altair 8800 and Apple I, introduced around 1975, marked the release of low-cost 8-byte processor chip, which had sufficient computing power of interest to hobby and experiment users. By 1977, pre-assembled systems such as Apple II, Commodore PET, and TRS-8 began the era of mass-market home computer. Much less effort was required to obtain an operating computer, and applications such as games, word processing, and spreadsheet began to proliferate. Distinct from computers used in homes, small business systems were typically based on Computer M until IBM introduced the IBM PC, which was quickly adapted. The PC was heavily cloned, leading to mass production and consequent cost reduction throughout the 80s. This expanded the PC presence in home, replacing the home computer category during 1990 and leading to a current monoculture of architectural identical personal computer. This is timeline for computer system and the important hardware. 1958 transistor, 1960 DIC BDB, 1961 Fairchild resistor transistor, 1962 NBN transistor, 1963 mouse, 1964 DCD, DCD-DC, 1965 DIC BDB, 1966 integrated circuit, Fairchild built first MOS, Data General Nova, 1969, 1969 Honeywell, transistor, and the sequence of advancing these computer. Thank you.